Thank you for your interest in Filtamatix Hepa filters. Hepa filters by design are vital to ensure the protection of personnel, product and equipment in industries such as healthcare, pharma, nuclear, life sciences and gas turbine industries. Join us on a journey through the Filtamatix Hepa manufacturing plant to answer the following questions. Can I really trust and rely on the quality of Filtamatix Hepa filters? The manufacturing process starts by loading a roll of microglass filter media onto the pleating machine and recording the roll number onto the quality control form for 100% traceability. Hepa microglass filter media is selected in grades H13 to U17, which have been tested for its ability to retain the most penetrating particle size, commonly referred to as MPPS. The MPPS test is conducted by using a light scattering spectrometer or condensation nucleus counter. The most penetrating particle size has generally been found to be between 0.1 and 0.3 micron. During the manufacturing process, several lines of thermosetting resin is dispensed onto the filter media using a microprocessor control system. The temperature and flow rate is controlled to provide the exact amount of resin at all times. The media feed rate is likewise carefully controlled by means of a PLC controller, and the pleat height can be adjusted to suit the filter performance. The thermosetting resin creates a separator between the pleats to ensure total media utilization and to create a rigid filter pack. Each filter pack is stored in pre-assembly racks pending assembly into the filter frames, which could be manufactured from galvanized steel, stainless steel, aluminium or plastic. The quality control documents reflect all the data for traceability and compliance to ISO 9001 quality standards. Due care is taken when sealing the filter media to the filter frames, because a single pinhole leak will result in filter failure. Visual inspection is done on each filter, but the defining factor for efficiency and compliance is determined when the Hepa filter is subjected to DOP testing procedures. The manufacturing process is completed by incorporating a gasket to the Hepa filter face. The quality and type of gasket cannot be emphasized enough. When one expects a Hepa filter to remove essentially all particulate matter down to 0.01 micron, the gasket becomes a vital component in the manufacturing process of Hepa filters. The importance can be seen in the capital investment required to produce Hepa filter gaskets, which is in the region of 2.5 million South African rand. A fully automated CNC machine applies a seamless urethane gasket to guarantee leak-free Hepa filters. Nothing is left to chance at Filtamatix to guarantee Hepa filter performance at all times. Note how evenly the compression levels are applied when combining Filtamatix Hepa filters with FMX Camlock Positive Seal Hepa housings. Perfection each and every time. Specialized equipment is required to test and validate Hepa filters, starting with a thermal generator. During earlier years, DOP, which is dioctyl phthalate, was used as an aerosol source when testing Hepa filters, but this has largely been discontinued because heated DOP gives off phthalic anhydride, which is a known carcinogen. As an alternative, mineral oils have been developed as a safe alternative to DOP. When heated to 316 degrees Celsius and in the presence of an inert gas, condensing aerosol is generated with literally millions of particles in the 0.1 to 0.25 micron range. The aerosol is injected by means of a positive injection pump to the upstream of the Hepa filter under test. The aerosol is evenly distributed across the filter face at a concentration level of between 20 and 80 micrograms per liter, resulting in a massive amount of thoroughly mixed aerosol to really challenge the filter under test. The second device that is needed when testing Hepa filters is a photometer. In simple terms, this is an extremely sophisticated device which detects and measures DOP aerosol downstream of the Hepa filter under test to determine its efficiency. Modern photometers are able to measure and record penetration levels as low as 0.0001% at particle sizes between 0.05 to 1 micron. This meets the criteria for all Hepa and ULPA filters in accordance with EN 1822 international test standards. In modern manufacturing facilities such as ours, the photometer sampling probe is connected to an automatic CNC scanning system which traverses across the outlet of the filter under test at a speed of precisely 50 millimeters per second to guarantee the very best and most reliable analyses. The DOP penetration value, which determines the Hepa filter efficiency, is recorded and downloaded directly to a computer from which the test report will be generated. This automated process eliminates human error, which can happen during manual scanning processes. No Hepa filter will be dispatched from the factory unless it has been tested and found to be compliant to the performance requirements. A unique serial number is allocated to each Hepa filter, and a test report is issued as proof of compliance to EN 1822 international test standards. In addition to the efficiency tests, the differential pressure at rated airflow is measured and recorded on the test report for each Hepa filter. Filtamatix, a proudly South African company with first world quality assurance systems combined with uncompromising ethics.